What if I told you there's a single, elegant law that connects everything in the universe, from the tiniest quantum vibration to the spiraling dance of galaxies, from the spark of life to the mystery of consciousness itself? It might sound like science fiction, but a groundbreaking new theory proposes exactly that. It's called Boko Dual Gravity, or BDG, and it might just be the key to understanding reality in a way we've never imagined. Stick with me, because today we're diving deep into a revolutionary idea that could reshape science as we know it. This isn't just about physics or biology, it's about the unified fabric of existence. So, what is this universal law? At its heart, it's incredibly simple. The theory says everything, and I mean everything, operates on a dynamic relationship between two fundamental fields. Let's call them the A field and the B field. The A field represents everything external, chaotic, and uncertain. Think of it as the raw, untamed energy of the universe, the constant influx of entropy and information overload. It's the receiver field. The B field, on the other hand, is the opposite. It represents internal structure, stability, and order. It's the integrator, the part of a system that creates meaning and organization from the chaos of the A field. The core idea of Boko Dual Gravity is that all systems, from a single cell to an entire ecosystem, are constantly driven to move from A to B, from chaos to order, from uncertainty to stability. This isn't just a tendency. It's the fundamental direction, vector, of reality itself. The dynamic difference between these two fields creates what the theory calls transformative energy, or E. This is the engine of change, the force that propels all existence. But it gets even more fascinating. The theory suggests a cosmic oscillation, a universal rhythm. Systems use this transformative energy, E, to expand and explore, but they always return to their state of internal order, B. Think of it as a cosmic breath. Expansion and contraction, energy and structure, E and B, over and over. This rhythm is everywhere, a fractal pattern repeating at every scale, from the vibrations inside an atom to the majestic spin of a galaxy. This is what the theory calls micro-macro fractal symmetry. The same basic law that governs a quantum particle also governs the cosmos. The universe, in this view, is a single, self-similar, living organism. Now, where does consciousness fit into this grand picture? This is where it gets truly mind-bending. The framework introduces a model called CHG, consciousness, harmony, and geometry. Here, consciousness isn't just a byproduct of the brain. It's defined as the most powerful force for creating order in the universe. It's an active, negentropic engine. Harmony is the coherence, the alignment of rhythms and frequencies that allows order to emerge. And geometry is the physical shape, the spatio-temporal form that this order takes. Think about it this way. Every time you have a conscious intention, you are actively participating in this cosmic process. Your intention takes the infinite possibilities of the chaotic A field and collapses them into a single, new, ordered reality in the B field. You are literally creating a new quantum geometry in space-time with every focused thought. This moves consciousness from a philosophical idea into something measurable, a quantum neurobiological process. It builds a bridge between physics, biology, and neuroscience, offering a unified language for all of them. So, if this theory is so powerful, why haven't you heard of it on the evening news? Why is there a relative silence in the mainstream scientific community? Well, the history of science is filled with revolutionary ideas that were met with resistance at first. Think about it. First, scientists, like anyone, are often risk-averse. Endorsing a brand new, paradigm-shifting idea can be a career risk. It's safer to stick to established theories. Second, this theory is deeply multidisciplinary. It connects quantum physics, biology, systems theory, and neuroscience. Most academics specialize in just one of these fields. To truly grasp this model, you need to think across boundaries, which can be intimidating. It requires a nonlinear, relational way of thinking, seeing the whole picture at once, which is rare in a world that prefers breaking problems down into smaller, linear parts. And let's be honest, this model challenges everything. It offers a new interpretation of energy, a new definition of consciousness, and a new vision of biological geometry. Revolutions always face resistance. It's the nature of progress. Even Einstein's early papers took time to be understood and accepted. New ideas that are multi-layered can feel heavy or complex at first, but heavy ideas are strong ideas. They have staying power. So, where will this theory likely gain traction first? The first wave of acceptance will probably come from the pioneers, the researchers working on the cutting edge. Quantum biology is a prime candidate. This field is already exploring phenomena like biophotons, cellular quantum processes, and structured water. Ideas that resonate perfectly with the BDG model. Systems biology is another, as its focus on input, organization, and feedback loops mirrors the entropy cycle. Researchers in artificial intelligence and consciousness studies are also likely to take notice. As we try to build artificial awareness, models like BDG that provide a mathematical framework for consciousness become incredibly valuable. And finally, theoretical physicists studying energy fields and philosophers of science will find a rich, new landscape to explore here. The adoption of such a massive idea won't happen overnight. It's a marathon, not a sprint. We can expect a realistic timeline. The first few years might be a period of silent acceptance, where academics read the papers but don't comment publicly. Then, over the next decade, we'll start seeing the first citations. Young, bold researchers will begin referencing the ABI model, the new interpretation of entropy, and the quantum biological perspective in their own work. In about 15 to 25 years, we could see the theory enter major scientific debates. It might be taught in university classes and compared with other models in major papers. And within a generation or two, concepts like the entropy transformation could become a standard part of the scientific language, just as concepts from relativity and quantum mechanics are today. Remember, it took 20 to 30 years for Einstein's theories to be fully embraced. Great ideas take time to mature. But why is this journey so important? Why should we care about a complex theory that might take decades to prove? Because these ideas expand our vision of what it means to be human. By placing consciousness directly into the mathematical framework of physics, this theory achieves something science has struggled with for centuries. It creates a unified mathematics for the triangle of energy, life, and consciousness. It teaches us to see nature not as a collection of separate parts, but as a single, interconnected system. In this view, we are not just biological machines on a random rock floating in space. We are an integral part of a much larger cosmic architecture. We are active participants in the universe's continuous journey from chaos to order. This model elevates our place in the cosmos, suggesting a future where our understanding of ourselves evolves. This unified theory offers a profound and optimistic vision for the future of science. It's a future where the lines between disciplines blur, where we see the universe not just as a physical machine, but as a mental, biological, and systemic whole. It's a future where we understand that the drive to create order, to learn, and to be conscious is not just a human trait, but a fundamental law of the cosmos. The journey of these ideas is just beginning. But one thing is for sure. They have the power to change not only how we see the world, but how we see ourselves within it. Thanks for watching. If you found this as mind-blowing as I did, be sure to like, subscribe, and hit that bell so you don't miss our next deep dive into the future of science.